Hello everybody, my name is Steffan Sorenes. I am a leading advisor industrial IT in Equinor, and I will now say something about OPC UA's role in becoming a digital energy company with data-driven operations. Equinor is a broad energy company with 21,000 colleagues committed to turn natural resources into energy for people and progress for society in more than 30 countries worldwide. We are dedicated to safety, equality, and sustainability. We are the largest operator in Norway. We are a leading international offshore operator, and we are a growing force in renewables. So we are shaping the future of energy. Equinor's strategy is based on three pillars: always safe, high value, and low carbon. To reach this strategy, to reach our ambitious goals, we need to stay in the forefront of digitalization. We need to implement at scale and create value from new digital tools and technologies. So digitalization is here to transform the way we work, support our strategy, support our goals, so that we, for instance, can use data to improve safety, reduce our development and operating cost, increase recovery and discovery, and also reduce greenhouse gas emissions. We have a company-wide digital roadmap in Equinor, and this roadmap is centered around 6 digital programs cutting across the company. And we have 3 key enablers. That is developing digital capabilities and leadership. We would like to utilize the external ecosystem. And we have and are still developing our unified data platform called Omnia, based on Microsoft Azure. So in Omnia, relevant data is made available independent of its source or its point of creation in the value chain. So the idea behind our platform called Omnia is to move from silos of data across our value chain to one common data platform that orchestrates all our data across the value chain. So one of the programs in our digital roadmap is data-driven operations. What is that? It's really about using data to maximize the asset value through things like production, optimization, maintenance, improvements, etc. For me, it boils down to the following 4 enablers or success factors to become data-driven. First of all, you need data. You simply need data to be available if you aim to run your business based on data. The challenge in Equinor and many other industrial companies is that data today is tightly coupled to many applications, software systems, where each application have their own data interface, their own data model, their own data access regime, etc. But data is not enough. You also need context. So data without any context is quite useless. You need context to ensure that both humans and machines really understand what the data means in order to use it. And then, third point, analysis and visualization. So when you have data, you have context, which together becomes information. Make it available to humans and machines for analytics, for visualization, for usage. You need to use the data, use the information. And the final step is to make decisions. So make decisions, faster decisions, better decisions, based on the insights derived from contextualized data and/or analyzed data. And in my opinion, OPC UA is really here helping us with the 2 first points. It's about data and it's about context. This is a very high level OT IT landscape that we have in Equinor, that I also believe many other industrial companies have today. So we have many industrial asset intensive plants, the physical world out there, with machines, with equipment, with field instrumentation, with real-time embedded computers, controllers, PLCs, etc. And then we have the process control system together with the human machine interface. We have various condition and performance monitoring systems running on the plant floor. And these systems have for a long time made real-time sensor data available using the classic OPC standard. And this all this data from these various servers on the plant floor are collected in a central OT IT gateway in the DMZ zone at the plant. And from this gateway, data is then made available from one interface to various applications in the IT domain used for monitoring, optimization, analytics, etc. So the green dots here are the classic IT on-premises network and data center, where you have historians with related ecosystem, etc. And then the last years we have the blue dots here, which is the cloud. So more and more of the data is moved to the cloud, where internal projects and initiatives, but also external, like suppliers, partners, vendors, etc., are accessing the data using various APIs. So OPC have been with us for a very long time, many decades, and now we are evolving this into OPC UA. Time series and sensor data made available from instrumentation and sensors from the industrial automation and control systems to the IT domain for monitoring, analytics, optimization, decision support, etc. It looks like this. It's quite simple. It is a name, it is a value, a quality bit, and a timestamp. And if you are lucky, you get additional metadata such as the engineering unit and a description, but that is not very often the case actually. However, this sensor data is quite useless without any additional context. You know that this data is measuring something, but what exactly? Some people with years of hands-on experience from a particular plant or plant system, they know this by just looking at the name. But for many people and subject matter experts in the business, that tag name doesn't make much sense. So both humans and software and machines, they need additional context in order to make this sensor data actionable. And sensor data combined with the right context give you information you can start to act upon. So this data is measuring something, but what? Is it measuring something related to a pump? Is it an engine, a valve? Or is it some fluid? Is it upstream? Is it downstream? What is it? You need context. And this is, to our opinion, the most powerful game changer in OPC UA, with OPC UA. That is OPC UA's ability to really turn data into information, have data in context using the OPC UA information modeling framework. And second, OPC UA's ability to standardize on the context, standardize on the information across vendors, across products by using the OPC UA companion specifications, the standardized OPC UA information models. And this is about interoperability. That is in my opinion, the main intention with OPC UA. So OPC UA as an open, international, industry-independent and secure connectivity framework is supporting us in making real-time contextualized data available. And that is basically 2 out of 4 pillars to become data-driven. But in my opinion, to do this at scale and with speed, you need interoperability. And interoperability for Equinor in this OTIT landscape implies that similar information is described, defined, organized in a standardized way, independent of vendor and system and component and product, etc. It means that we need to agree on common and open formats, on information models and connectivity standards, and we need well-documented and understood interfaces, both for machines, for software, and humans. Our plants are quite heterogeneous, meaning we have many different vendors delivering software and hardware on the same plant and across plants. And if each vendor is delivering the same type of data in different vendor and system-specific interfaces with vendor and system-specific information models and semantics, then we need to have humans, our good engineers, they need to spend more time on interpreting, mapping, transforming, and preparing the data instead of using the data to support our roadmap and business strategy. So therefore, interoperability is very important for us to achieve scale and do this with speed. This is an example of an OPC UA server, a really rich object-oriented structure where you can browse the context and understand what the data means. But an OPC UA server can also look like this. This is an OPC UA server, but we don't want suppliers making their data available like this in their OPC UA servers. This is quite useless, this information we find in this server. So it is important going forward that we, meaning the entire industry, need to agree on standardized information models for given domains and assets. OPC UA is implemented, it is proven in use at scale at one of our largest fields called Johan Sverdrup. And we are implementing OPC UA at scale in our ongoing greenfield projects, and we also see this coming at brownfields as well. So Johan Sverdrup started production. It's an oil and gas field. It started production in October 2019. And this field alone will produce 30% of Norway's total production. So this is massive. OPC UA have been a central part of the digitalization strategy for Johan Sverdrup since 2015. Today we have 19 OPC UA servers running on the plant floor, which is aggregated into one central OTIT gateway by using the OPC UA aggregation architecture pattern. In the Johan Sverdrup project, we also developed some information models in OPC UA that we have shared back to the community and made open source because we utilize the OPC UA community. We get benefits from this community, and by open sourcing these information models, we also contribute back to the community because we believe that being open is the key to achieve adoption. And we believe openness is in the spirit of OPC UA. So at the end, what are the benefits for Equinor as an operator, as an end user? And I see at least 3 things. I see benefits around reduced total cost of ownership, and I see benefits around more innovation, more opportunities, and really enabling data-driven operations. When it comes to the cost, I see that we get more efficient exchange of data without needing human translators in the middle, and that is costly. And the key to succeed with that is standardized OPC UA information models. We are not there yet. It's a huge untapped potential, but if we succeed with this, I see really reducing the cost and doing exchange of data more efficient. I see that we get more flexibility in the overall architecture. It's easier to replace components, systems, etc., because the interface and the information model is the same across vendors. So you get this plug and produce effect. I also see that OPC UA is designed for and used across industry, and this is a real benefit because suppliers can then use the same interface and the same information model across customers, across industries, and I believe that in the long term will drive the cost down in the industry. On the innovation side, I really see that if we utilize the intention behind OPC UA with interoperability, we get easier, we get cheaper access to higher quality contextualized data from our plant operations, from our automation and control systems that we can use for monitoring, optimization, analytics, etc. in the IT domain. So we get access to more data, and that gives us new opportunities that we have not had before. We also get access to these ecosystems, communities around in the world. OPC UA is actually a community, and we must not forget that. It's an international community, so you get access to international expertise and competence all over the world, and that is also important for us. I also see that we get more competition if we use this the right way. This means that by using OPC UA, by using and embracing openness, standardization, interoperability, companies and people need to compete on business value and not compete on vendor lock-in. And that is also important. Going forward, what will we focus on? We need to do more when it comes to OPC UA companion specifications, so standardized OPC UA information models. It's a huge untapped potential. We are not there yet where we want to be, so we need to focus on a broader usage and scale up of standardized information models. And this is not only Equinor's job, this is the entire industry that needs to work on this. We would also like to have closer integration between the plant floor and applications and services in the cloud. That means that we need to make not only data, but also the context available from the OPC UA servers to the cloud. We are looking into more usage of automation, ML, and OPC UA together, meaning closing the loop between engineering and operations. And we are working heavily to align ourselves towards major international consortiums and initiatives like NAMUR, Open Architecture, Module Type Package, Open Process Automation, Forum, Platform Industry 4.0, etc. And they are all pointing at OPC UA as one of several key building blocks. And this is important because then end users have one voice towards suppliers when it comes to usage of OPC UA and information models and interoperability. And that is important so that we end users are not having hundreds of different voices and requirements to the same type of components and equipment, etc. So that's it from me. Thank you very much.